Good afternoon or morning, ladies and gentlemen. This is part B, or day 2 of the inverse functions in 7.4. Let's go ahead and get this bell ringer completed. All right, so what we're going to do is we're going to change f of x and y equals negative 3x plus 4, and then explain how you would complete the problem, or how we completed the problem. So we're going to switch, because we're going to explain right as we do. Switch x and y. So we're going to put x equals negative 3y plus 4. Now we are going to subtract 4 from both sides. We're trying to get y by itself. So I got x minus 4 equals negative 3y. Then we're going to divide by negative 3. So our y will equal x minus 4 divided by negative 3. There's my inverse. So after this, we divide by negative 3, both sides. Final answer is our inverse. Okay, and that's it. We're moving down into the new lesson. We're verifying whether or not two functions are inverses of each other. So Lily and Alex are disagreeing with each other. Lily says the inverse of y equals 2x plus 4 is equal to y equals a half x minus half. But Alex says that isn't the inverse, and who is correct. I find the easiest way, or most simple way to do this, is literally just take one of the functions. We're going to go ahead and just switch the x and y around, and then we'll get y by itself. So at this point, I divide everything by 2. So that's a half x minus 2 equals y. That would be my inverse to this. These are inverses. Now, it's darn close to being the inverse. However, the 2, or the negative half, is not the same as negative 2. So therefore, the young man Alex is correct, or young lady. They are not inverses. Okay. Moving right along. So what we're basically doing here is we are testing to see if these functions are inverses or not. I'm going to do this one because that looks like it's more simple. Switch the x and the y. Remember, you get to pick between the two. Switch x and y. We're now going to subtract the 8 over. And then we're going to divide by 2. So this is a half x minus 4 equals y. And the answer would be yes. These are inverses. Okay? Going to number 2. I'm going to do this one. I'm going to switch the x and the y. So I get x minus 2 equals y. And again, these are the same. Okay? So yes, they are inverses. Tell me to write yes or no. Yes, they are inverses. Going to the second page. More the same. Remember, we're going to write yes or no if they work or not. I'll make this a tad larger. Right, so which one do I think is easier? I think this one's easier. So I'll switch x and y here. Then I'm going to add 6 over. So x plus 6. And these are not. Okay? They are not inverses. So I will write no. Clearly, these two are not equal. Moving right along. This guy looks like it's the easiest. So x equals negative 3y plus 6. Subtract that 6 over. And then I'm going to divide everything by negative 3. So this is negative 1/3 x plus 2. And yeah, these two guys look like the same thing. So, yep, they are inverses. All right? Now it looks like we got two more difficult ones down here. Let's give them a shot. With 5 and 6. I'm going to go here. So that would be x equals 4y plus 1. Subtract 1 over, and then divide everything by 4. So it looks like y equals 1/4 x minus 1/4. Oh, that's so close. But this one has a negative, this one does not. So no, we are not inverses. All right, the challenge one. Let's see here. Oh, they're both kind of ugly. No offense. First thing I'm going to do is get this y by itself. So 7y equals 3x plus 14. So I added this 3x over. And then going to divide by 7. So I'm going to get y equals 3/7 x plus 2. That's my original. Now let's get the inverse, shall we? So I'm going to switch x and y. I'm going to subtract the 2 over. So that'll be x minus 2. I am then going to multiply this 7 out of the denominator. This is 7x minus 14 equals 3y. I will then follow up by dividing by 3. So it looks like my inverse will be y equals 7/3 x minus 14/3. Okay, so this is my original, that's my inverse here. Alright, now to be able to compare these, I have to get y by itself here. Okay, so I'm going to do that work up here. So I'm going to subtract 7x over, so I have negative 7x plus 14 equals negative 3y. So I subtracted 7x over. I am then going to divide by negative 3. Okay, so we are comparing this and this. Okay, so 7 7/3 x, 7/3 x. Negative 14/3, negative 14/3. Are they inverses? Absolutely. That's a lot of work for that one. Okay, so make sure you take your time. So you have to solve both for y, and then switch the x and y one on and solve it. All right, going to your word problem. Finish this up. We got 2 of them. All right, so for real life application, the formula to convert temperatures from degrees Fahrenheit to degrees Celsius is C equals 5/9 F minus 32. We're going to write the inverse of this function, which converts temperatures from Celsius back to Fahrenheit. Then we're going to find the Fahrenheit temperatures that are equal to 29, 10, and 0. So what we're going to do is we're going to go F. We're going to find the inverse, so F and C will get switched. Okay, and I'm going to basically multiply that 5/9 over. So I multiply by the reciprocal. This 9/5 and 5/9 cancel out. C minus 32 is equal to 9 over 5 times F. I then add 32 over. So we're looking at a formula that would be C equals 9/5 F plus 32. Okay. Okay, now that's our inverse function, but in order to find the Fahrenheit temperatures when this is 29, 10, and 0, we actually switch the F and the C. So if we actually want to apply this to a real life problem, we're going to have to switch them back. That would be C plus 32, and we're going to go through this 10 different times. So we'll do 29 degrees Celsius. So this will be 9/5 times 29 plus 32. Okay? And then when we do C is equal to 10, this will be, sorry, I changed this to F, right? So that should be F. So I got F equals 9/5 times 10 plus 32. This one's nice because this will be 2. 2 times 9 is 18. 18 plus 32. We're looking at 50 degrees Fahrenheit. And if I do C is equal to 0 degrees, yeah, 9/5 times the 0 plus 32. So that'll be 0 plus 32, which is 32 degrees Fahrenheit. Right? As for the other one here, now I'm going to need a calculator because 29 is not divisible by 5, so this would be a nice long decimal. So when I take 29 divided by 5, I get 5.8. Then I'm going to multiply by the top, which is 9. So this will be approximately 52.2. Then I'll add that 32 on there, so I'm looking at a temperature of 84.2 degrees Fahrenheit. So there are my 3 temps that I get when I convert Celsius back to Fahrenheit. Okay. Last 2 problems here. I'm going to create 2 pairs of functions that could or could not be inverses of each other. Another person will then solve the problems and decide for each one whether or not they are inverses. It should look something like this. So here are the 2 I'm going to test. Let's start with this one. Switch x and y. We are just going to test to see if this works. This is what the person would have to do in order to show that they're inverses or not. So this does not match this. They are not the same. So you should say they are not inverses. It's the same thing here. Okay, let's switch the x and the y. So I'm going to add the 10 over, and then I'm going to divide by 5. So this is x over 5 plus 2 equals y. And again, this is not the same as this, so they are not inverses. Okay? So that's how you would do that. Guys, if you have questions, please email me. Do what you need to do, okay? You know where I'm at. I'm here to help, so catch you in class.